Hi everyone and welcome to intersection calculations. So let's start with the aim of the intersection, guys, which is very simply to calculate the coordinates of one unknown station. Let's call it x, for example, from two known stations A and B. So these are two known stations. That means we know their locations on the ground and also we know their coordinates easting and northing. And our aim in today's session, guys, is to calculate the coordinates of this unknown station x. Before I start, it's very important to mention the similarity between the resection that I explained in details in a previous video and the intersection. Okay? The aim of the resection and of the intersection is the same, is to calculate the coordinates of one unknown station x from two known stations A and B. In the resection, if you remember, we set up the total station over station x, over the unknown station x, and we collected some observations to do the calculations. The main difference between them, in the intersection, you cannot set up your total station over the unknown station because for some reason it's inaccessible. Okay? If you cannot reach or you cannot set up your total station over a point of your interest or a survey station that you are interested in, you can use and apply the intersection procedure. Okay, so this is the main difference between the resection and the intersection. To do the intersection calculations, guys, we need to do some observations using total station. The observations are very simply measuring two horizontal angles A and B, angle A and angle B, using total station. And we know the coordinates of these two known stations. We will use them in the calculations. This is very simply the required data, just measuring two horizontal angles A and B. So as usual, guys, let's start by using some numerical example. This will help us a lot in understanding the whole procedure and the whole process. So in our example, guys, we have the coordinates of the known survey stations A and B, easting and northing of A, easting and northing of B. They are given in this table here. This is easting of A, northing of A, easting of B, northing of B. So we have all the coordinates for these two known stations. And also using total station, we have measured two horizontal angles, angle A, this one, which is in this case 79 degrees, 11 minutes and 7 seconds. And we have angle B, and its value is 62 degrees, 11 minutes and 12 seconds. And our aim, of course, is to calculate the coordinates of this unknown station x, which is this one here, easting and northing. Okay, so for the measured values, guys, these values, if you don't know how to measure horizontal angle using total station, I explained this in a very detailed way in a separate video. You can watch this, which is called Measuring Horizontal Angles and Distances. And also, before we start, it's very important to understand the principle of the whole circle bearing and sighting north. And also I explained this in a separate video. Please do watch this video because it is very important. Everything that we are going to do today is based on your understanding of the whole circle bearing principle, which is very easy and simple, but you need to understand this. So I summarized the whole process, guys, in four main stages. The first stage is we need to calculate the whole circle bearing of AB and the whole circle bearing of BA. After that, we are going to apply the sine rule to calculate distances XA and XB. This distance XA and this distance XB. We need to calculate these using sine rule. After that, we are going to calculate the whole circle bearing of AX and the whole circle bearing of BX. And finally, we are going to calculate the final coordinates of the unknown station X, and this is our aim. So let's get started with the calculations. We have these numerical values, okay, guys, and we are going to use them to calculate the coordinates of the unknown station. The first stage, guys, which is calculating the whole circle bearing of AB and BA. As you know, to calculate the whole circle bearing, we are going to start with calculating the change in easting and the change in northing between these two stations. The change in easting is very simply delta E AB is easting of B minus easting of A from the table here. We have this is easting of B and this is easting of A. The difference between them, in this case, I calculated that to be 35.6 meters. And then we are going to calculate delta n, the change in northing, which is northing of B minus northing of A. This is northing of B in the table, and this is northing of A. Very simply, we are going to find the difference between them, and in this case, the difference is minus 53.2 meters. Now we are going to calculate the length of this line AB, guys. Using this very simple relation, the length of line AB is the square root of delta A squared plus delta N squared. We have delta A and delta N here. These are the values of delta A and delta N. So let's apply. So the square root of 35.6 squared plus 53.2 squared. And the answer is 64.12. So this is the distance or the length of the line AB, this one. Now we are going to calculate the quadrant bearing, which is the inverse tangent of the absolute value of delta A divided by the absolute value of delta N. So delta A and delta N, don't forget from the first step here. We have calculated them in the first step. Okay, let's use the numbers. So the quadrant bearing of AB is the inverse tangent of 35.6 divided by 53.2. And the answer is 33 degrees, 47 minutes, and 21.72 seconds. So this is the quadrant bearing. And the last step, which is the whole circle bearing of line AB. In this case, it would be 180 minus the quadrant bearing. And this is the quadrant bearing, guys. We have just calculated that. So here it would be 180 minus 33 degrees, 47 minutes, and 21.72 seconds. And the answer is 146 degrees, 12 minutes, and 38.2 seconds. So this is the whole circle bearing of AB. Now we are going to calculate the back bearing, or the whole circle bearing of BA, which is the whole circle bearing of AB that we have just calculated here, plus 180 degrees. And the answer is 326 degrees, 12 minutes, and 38.2 seconds. Okay, guys, now we have calculated the whole circle bearing of line AB and the whole circle bearing of line BA. So before we move to the next stage, I would like to mention again to remind you that if you have any issue with this stage, if you don't understand what is the quadrant bearing, if you don't understand what is the change in easting and change in northing, why here it's 180 minus the quadrant bearing, why here the back bearing is the whole circle bearing plus 180 degrees. If you have these questions in your head now, please stop here and go to that video, whole circle bearing. Watch that video because it's very important to understand it, and then return here and continue on this video. Yeah, so let's go ahead, guys. The next stage, guys, which is calculating angle X, this angle, and the length of line AX and BX. This one AX and this one BX. First, to calculate angle X. Very simply, guys, we know the value of angle A, we know the value of angle B. These are measured using total station. Okay? And you know that the summation of the triangle angles should be 180 degrees. So because of that, to calculate the value of the angle X, very simply, it is 180 degrees minus angle A minus angle B. And in this case, 180 minus, this is the value of angle A, this is the value of angle B, and these are known values. In this case, the answer would be 38 degrees, 37 minutes, and 41 seconds. So this is angle X. Now we know all the angles of this triangle. Let's calculate the length of line AX and the length of line BX. So let me quickly remind you about the sine rule, guys. So here, let's go here. The sine rule very simply says in any triangle, if you have the length of this line, for example, AX, divided by sine angle opposite to it, which is in this case angle B. So the length of AX divided by sine B should be equal to the length of BX divided by sine A. So the length of BX, this one, divided by sine angle opposite to it, which is sine A in this case, and should be equal to the length of the third line, which is AB in our case, divided by sine angle opposite to it, which is sine X in our case, as you can see here. So we are going to use this rule to help us to calculate the length of AX and the length of BX. To calculate the length of AX, guys, this is sine rule here. So the length of AX divided by sine B should be equal to the length of AB divided by sine X. The only unknown here is the length of AX, because we know the length of AB. This is calculated in the previous slide. And also we know X. We have just calculated X here, angle X. And also we know angle B. This is measured using total station. Let's use the numbers, guys. So here this is the length of AB, 64.012 divided by sine angle X times sine angle B, and we have the answer here, which is 90.694 meters. This is the length of line AX. In a similar way, guys, we are going to calculate the length of line BX. We would use here the sine rule. The length of BX divided by sine A should be equal to the length of AB divided by sine X. From here, the only unknown as well is the length of BX, which is the length of AB divided by sine X times sine A. Okay, and A, of course, is known, which is measured using total station. Let's use the numbers here, guys. Okay, the only difference between this relation and the previous one is sine A instead of sine B. And here the answer, I calculated that to be 100.719 meters. So this is the length of line BX. Now let's move to the next stage, guys, which is calculating the whole circle bearing of AX and the whole circle bearing of BX. At this stage, as I mentioned, we need to draw a very nice and clear sketch. This will help us a lot to calculate the whole circle bearings. Just to remind you very quickly, what was the whole circle bearing in definition? It is an angle measured from north clockwise towards the measured line. Let's apply this on, for example, the whole circle bearing of BA. I started with letter B, so I'm over B. The whole circle bearing of BA, this is north, guys. It's an angle clockwise from north to line BA. This is the whole circle bearing of BA. What about the whole circle bearing of AB? I started with A, I'm over A. An angle from north to line AB. This is the whole circle bearing of AB. Okay. Now what about the whole circle bearing of AX? I started with A, I'm over A. An angle from north to line AX. This is line AX. This is the line AX, guys, yeah? This is A and this is X. So this is the whole circle bearing of line AX. What about the whole circle bearing of line BX? I started with B, I'm over B, from north to line BX. This is the whole circle bearing of line BX, this one. Okay? Angle from north to line BX. This is line BX. Now we have all of these whole circle bearings drawn on the sketch in a clear way, as you can see. Now this will help us a lot in calculating these values. For example, let's start with calculating the whole circle bearing of AX, this one. Don't forget that you know the value of angle A and you know the value of angle B. These two angles are known. They are here. All the known values, they are here in front of me to help me. And also the whole circle bearing of AB is known and the whole circle bearing of BA is known. Yeah, these are calculated in the first stage. So from the drawing here, the whole circle bearing of AX very simply is the difference between the whole circle bearing of AB minus angle A, this one. Yeah, so this is angle A, of course, here. And here this is angle B. So let's use the numbers. So the whole circle bearing of AX, guys, is the whole circle bearing of AB minus angle A. This is the whole circle bearing of AB. This is the value of angle A. I calculated that. It is 67 degrees, 1 minute and 31.2 seconds. This is the whole circle bearing of AX. Okay. Now let's calculate the whole circle bearing of BX. This small angle here, this one. The whole circle bearing of BX, guys, if you look at the drawing here, angle B, this angle, minus this value. Yeah. But what is this value? It's very simply, guys, a full circle. If you have a full circle like this, if you imagine here you have a full circle 360 minus the whole circle bearing of BA minus this value here. Okay, so 360 minus this value here will give us this one. So here of BA. So this is this angle. So let's write down this here. So the whole circle bearing of BX is angle B, as we have agreed, angle B minus this value here. And this value, as I mentioned, it is 360 minus the whole circle bearing of BA. So let's use the numbers that we know. And the whole circle bearing of BX is 28 degrees, 23 minutes, and 50.2 seconds. Now we have done calculating the whole circle bearings of AX and BX. As you can see here, this stage is very important, and it depends on the locations of these stations A, B, and X relative to each other. So guys, you need to draw a nice sketch of your 3 stations so that you can represent the whole circle bearings in a nice way on the drawing. Yeah, because this will help you to calculate the whole circle bearing of AX and the whole circle bearing of BX. Mostly if you don't have a nice drawing, a nice triangle, you would struggle at this stage. So now let's move ahead. Once you've done this stage, the last stage is very easy and simple. It's just calculating the final coordinates. Let's start calculating easting of X from station A. This is station A. You know easting of A? Yeah, easting of A is given here in this table. This is the value. So easting of A plus this distance will give you easting of X. But what is this distance? We will call it the change in easting between A and X. We are going to calculate this now. And in a similar way for northing. Northing of A, this is northing of A, plus this distance, which is the change in northing between A and X, will give you northing of X, NX. Yeah? So now we are going to calculate the change in easting and the change in northing. From station A, let's start from station A. The final coordinates of station X, the change in easting between A and X is the length of AX times sine the whole circle bearing of AX. The length of AX is known. We have calculated that using sine rule. The whole circle bearing of AX is known. We have just calculated that in the previous slide. Yeah. So the answer is 83.5 meters. The change in northing, the same relation. Instead of sine, use cosine the whole circle bearing of AX, and the answer is 35.4 meters. Now we have calculated the change in easting between A and X and the change in northing between them. Now easting of X is easting of A plus the change in easting, which is in this case 809.2 meters. Northing of X in a similar way is northing of A plus the change in northing between A and X, which is this one. This is the change in northing, guys, and this is change in easting. Yeah, and we have here now the final northing coordinates of station X, 1320.6 meters. So now by doing that, we calculated the coordinates of the unknown station X, and this was our aim in the whole session. Now to check our work, we are going to calculate the same coordinates but from station B now. We will use the coordinates of station B. The coordinates of station B, they are given here in the table. This is easting of B, this is northing of B. Yeah, so let's do that check because it is very important. So this is station B, guys, here. So this is easting of B plus delta E between B and X. We will get easting of X. So, and this is northing of B. And this is delta M between B and X. And this is northing of X. The same relations we are going to use here. Delta E between B and X, the length of BX times sine whole circle bearing of BX. We know the length of BX, we know the whole circle bearing of BX, just use the numbers, and this is the value. This is delta E between B and X, 47.9. Delta M between B and X is the length of BX times cosine the whole circle bearing of BX, and it is 88.6 meters. Finally, the coordinates, easting of X equals easting of B plus delta E between B and X, which is this one. And this is the answer. And the northing of X, which is northing of B, plus delta M between B and X, which is this one. Okay, guys, now we have calculated the coordinates of station X from station A and we used station B to check our answers. So let's compare them. Easting of X, it's 809.2 meters, the same here and here, so this is correct. And northing of X is 1320.6, and here 1320.6, and this is correct. So our all of our calculations are correct. So now guys, we can say that the final coordinates of the unknown station X are 809.2 meters east and 1320.6 meters north, and by doing that we have achieved our aim and calculated the coordinates of the inaccessible survey stations X by taking measurements or observations using total station from two other stations A and B. Okay, I hope that you enjoyed this video guys, and you learned something new that might be useful to your work. So in your project guys, if you have a station that you cannot access and you are interested in calculating its coordinates, you can use this method, which is the intersection calculations. Thank you very much for listening guys, and enjoy the rest of your day. Bye now.